Hey everyone, it's me, Mr. Morris again. We are doing another video in our answer key to the AP Summer Homework. This is Summer Homework Chapter 1, question number 10. This is a density question. It's actually several questions kind of rolled into one. We're given a bunch of density information at the top of the page, and then we're just asked a bunch of scenarios. It says in each of the following pairs, which has the greater mass? So we're just wondering which one is a greater mass. And we want to explain and or calculate for each comparison. I'm going to start with explaining, okay? So we're looking at 1.0 kilograms of feathers or 1.0 kilograms of lead. All right. I hope that you recognize that both of those are the exact same number. Not only that, they're the same units, but then we need to think about what the units represent. Kilograms are units of mass. So because it's the exact same number and the same unit of mass, they have the same mass. Okay? So really, there's not one that has a greater mass. They have equal mass. So the answer to this would be the 1.0 kilograms of feathers and the 1.0 kilograms of lead both have the same mass because kilograms are a unit of mass and 1.0 is the same number in both cases. Okay, let's go on to the next one. I guess I shouldn't scoot it down that far. We're going to have to look at those numbers. All right, 1.0 milliliters of mercury or 1.0 milliliters of water. All right, now milliliters, that's a unit of volume, okay? So we can think about it qualitatively. We have the same amount of volume, and if we have the same amount of volume, which one's going to have the greater mass, the higher or lower density? Same volume, greater density will have a greater mass. So I'm looking at this one, mercury and water. Well, if I compare those, mercury has a much greater density than water does. So I could say because we have equal volumes of mercury and water, the mass of mercury is greater because mercury has a greater density than water does. You could explain it with words like that, and you could write that out. Another way you could do this is actually by solving for the density, okay? Or solving for the mass, I'm sorry. But we'd use our density equation. Density, mass, volume. Okay, so for mercury, our density is 13.6. Our mass, don't know. Our volume, 1.0 milliliters. Okay, for water, density equals 0.9982, and I should be labeling these grams per milliliter, grams per milliliter. If I'm going to justify this with work, mass, don't know, volume is 1.0 milliliters. Okay, now we want to set up our problem. Let's just do that real quick. Density is 13.6. Density equals mass over volume. So mass is unknown. Volume is 1.0. I can cross multiply. So 13.6 times 1 is 13.6. And m times 1 is m. So m equals 13.6. Now really we should round this to the correct number of sig figs. So that would be 14 grams, according to our sig figs, right? All right, let's continue. Now let's do this one over here, 0.9982. Density equals, and then we have mass over volume, m over 1.0. Okay, put a 1 there just to make it a little easier for cross multiplication. 1 times m is m. Equals 0.9982 times 1. So it's going to be 0.9982. Now if I were to actually round that up, instead of 0.9982, I want to round it to 2 sig figs. These two, can't do that. That would just round up to 1. So to 2 significant figures, this is 1.0 grams. All right, so our question stands: which of these has a greater volume? Now, I justified it with words earlier, and that's totally fine. That would have been a fine way to answer this question. In this case, I've chosen to show some math, but I still need to answer the question. What does it say I need to do? Tell you which one is a greater mass. And if you fail to answer a question, even if you do all the work, you fail to answer the question, you're going to lose points. So we've still got to write down mercury has a greater mass. And by the way, it's not that mercury always has a greater mass, but in this problem, mercury has the greater mass. Probably would be a better way of phrasing that. Now, you would probably rather actually write this out in like 2 sentences rather than showing all of that work, but I wanted to make sure that you understood there's 2 ways to justify your answer. It said explain and or calculate. So you can do either one with that question. Let's go down to part C. 19.3 milliliters of water or 1.00 milliliters of gold. Now this one, since our volumes are different, it's probably not going to work out as well for us to just explain it with words. I would go ahead and work this one out. So let's do it. And it's quick math. Let's kind of speed it up a little bit on this one. D equals, M equals, and then V equals. Okay, our volume for water is 19.3 milliliters. The mass, don't know. Okay, let's find the density for water. We actually used it just right up here, but just in case, 0.9982. Grams per milliliter. All right, and let's go ahead and just solve. Should have drawn a line there just to make it a little neater. It's okay. All right, let's go ahead and solve that one. Let's say I've got 0.9982 equals M over 19.3. Okay, let's put a 1 there. Okay. Cross multiply here, get our calculator out. I think I know the answer here, but let's just do it just in case. 0.9982 times 19.3. You get 19.26, blah, 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 but to 3 significant figures, how much is it? It's 19.3. M equals 19.3. And again, that was a cross multiplication. 1 times M is M. 0.9982 times 19.3. It rounds to 19.3 if we're just doing the correct number of sig figs. So 19.3 grams. All right. Go to the next part. We've got 1.00. Well, density equals mass equals volume equals. We have 1.00 milliliters of gold, an unknown mass, and then when we get to gold, right here, 19.32. 19.32 grams per milliliter. Okay, draw a little line there for neatness. And I've got 19.32 equals M over 1.00. Let's put a 1 there, cross multiply. M equals 1.00 times 19.32. We get 19.32, but don't forget we need to round according to the correct number of sig figs. I've got 4 here, got 3 there. This is actually going to round to 19.3 grams. You notice that these are actually the same number. Okay, so according to the sig figs that we have, we cannot actually say which one has a greater mass. Okay, they have equal masses. Now the question comes up, and it's a very reasonable question. Isn't this actually a little bit more than that? Ever so slightly? Well, it might be, but it also might not be, because I actually don't have as much information about water as I do about gold. So this could be 19.26 milliliters, or it could be 19.34 milliliters. I don't know which it is. It's somewhere in that range, okay? And that would change the calculation. So it's conceivable, it's possible that this has a greater mass. It's possible that this is a greater mass. You just have to look at your sig figs. And all we know for sure is 19.3. That 2 there, when we're actually plugging in a calculation with only 3 sig figs, we don't know for sure if it's exactly that number. So we can't identify whether they're slightly different or whether they're actually exactly the same. So all we can say, because of our significant figures, is they have equal masses. At least approximately, as far as we can tell, they have equal masses. All right, that one's kind of tricky. 75 milliliters of copper, or 1.0 liters of benzene. So let's do this. Density, mass, volume. Okay, density of copper. Start there. We're going to put 8.96 grams per milliliter. Mass is unknown. The volume, 75 milliliters. .96 equals, we're going to do M over 75. Let's put a 1 there. M times 1 is M equals 75 times 8.96. Just cross multiplying those two. 672. I want 2 significant figures, so I'm going to call that 670. Okay, 670 grams. All right, let's look at benzene. Benzene is right here, 0.880. Grams per milliliter. All right, mass is unknown. Volume is 1.0 liters. So I just do 1 times that, right? Careful. Okay, that's 1 liter. We need to turn it into milliliters. So don't forget, you've got those metric units. You've got the metric in the middle. Milli is over here on the right. And then we've got kilo over on the left. Okay, so liter is our base unit. We're going to go over 3 spaces to get to milli. 1, 2, 3. We're going to move the decimal 3 spaces. 1, 2, 3. So that's actually 1,000 milliliters. All right. Now we can solve. 0.880 equals M over 1,000. And it's with 2 significant figures. So 1,000 times 0.880. M equals, you're going to move that 3 spaces. It's going to be 880. And that's to two significant figures. All right, which of those has a greater mass? Out of these two, benzene has the greater mass. In this problem. All right. Hopefully that was a helpful review of some density concepts. Catch you next time.